Hello friends, let's discuss a colligative property which is very important. Elevation in boiling point. So elevation का मतलब क्या है? Increase in boiling point. Elevation means increase in a property or a behavior. Here the property under consideration is boiling point of a liquid. Boiling point of a liquid. For discussing this property, that is elevation in boiling point, or it is the behavior of a solution, of course, and it is the property of the pure solvent. The increase in boiling point is of the solvent on adding a non-volatile compound to it. For example, let's consider pure water. Here in a beaker we have pure water. At room temperature, on heating, its vaporization increases. We know that vaporization mainly depends on two factors. Number one, temperature. Number two, surface area of the liquid which is going to vaporize. These two factors are very important. Here we will increase the temperature and there will be a change in surface area on adding solute to the given liquid or the liquid under consideration. So rate of evaporation depends on temperature. With increase of temperature, there is a increase in evaporation process. With increase of surface area, there is an increase in rate of vaporization. With a decrease of surface area, there is a decrease in rate of vaporization. So because of decrease in rate of vaporization, less vapors are formed and vapor pressure is less, and hence the boiling point increases. Pure water boils at 100 degrees C. We know this fact, it is a fact. To this what we do, to the pure water we add, let's say, 200 molecules of sucrose. Now we have a solution of sucrose in water. Here on the surface, along with water molecules, let's say the water molecules. Here, what we have? The water molecules in vapor phase are present to less extent because on the surface we have some sucrose molecules. So this is your sucrose molecules. Sucrose molecule is represented by cross. So because of presence of sucrose molecules on the surface of water in the solution, less vapors are formed, so vapor pressure is less. So on heating, pure water boils at 100 degrees C, but here the vapor pressure of water in solution, because sucrose is a non-volatile compound. Here sucrose does not vaporize. We have less vapors. So in order to make the vapor pressure of water on solution, we have to heat the solution beyond 100 degrees C in order to make the vapor pressure of water in solution equal to 1 atmospheric pressure or external pressure. We have to heat the solution beyond 100 degrees C, and suppose here the solution boils at 100.05 degrees C. So 0.05 degrees C is the increase in boiling point or elevation in boiling point. Because of presence of 200 molecules of sucrose. Now in a third beaker, what we do, we take water, pure water, and to this we add, let's say, 100 molecules of sucrose and 100 molecules of urea. We are adding two different type of solutes, sucrose and urea, but the total number of molecules is 200. Again, the boiling point of this solution is 100.05. There is same increase in the boiling point on changing the nature of solute particles. These two examples, let's say solution B and solution C. Okay, please, हमारे पास we have two types of solutions, B and C. In B we have only sucrose, in C we have sucrose and urea, two solutes, but the increase in boiling point is equal. It means the increase in boiling point depends on number of solute particles, not on the nature. The increase in boiling point is a collective behavior of particles in the solution, and the particles may be ions, atoms or molecules. The increase in boiling point is not decided by the nature of particles, it is governed by the number of particles, and the particles may be of any substance. The increase in boiling point or elevation in boiling point is a collective effort of all the solute particles. That is why it is known as the colligative property, collective behavior of all the particles. So number of particles decide the numerical value of increasing boiling point, not their nature. And all such properties are known as the colligative properties. These are 4 in number. Let's see the graphical representation in the elevation in boiling point. Here in this graph, what we have? We have, let's say here, pure solvent at room temperature, let's say 25 degrees C, and on heating the pure water, its vapor pressure goes on increasing, and at 100 degrees C or 373 Kelvin temperature, the vapor pressure of pure water becomes equal to 1 atmospheric pressure, and according to definition, this is the boiling point of water or pure solvent. Boiling point is that temperature at which the vapor pressure of any liquid is equal to 1 atmospheric pressure, or you can say external pressure. But in case of solution, please, the escaping tendency of solvent molecules decreases or chemical potential decreases. At any given temperature, vapor pressure of any solution is less as compared to the pure solvent. You see here in pure water, and this is a solution of sucrose in water. Vapor pressure, again in case of increasing the temperature of solution, its vapor pressure, this is the curve in case of solution, also increases. And at 100 degrees C, you see please here, this is very important. At 100 degrees C, the vapor pressure of solution is less by this much value, delta P. This is a difference, please, delta P. The vapor pressure of solution at 100 degrees C is less by this value, delta P, as compared to 1 atmospheric pressure. And in order to increase the vapor pressure of solution up to 1 atmospheric pressure, we have to heat the solution beyond 100 degrees C, beyond 373 K, in order to make the vapor pressure of solution equal to 1 atmospheric pressure. we have to heat the solution further up to this temperature. Okay, up to this temperature. And the difference of these two temperatures, that is T minus T0, is the increase in boiling point, is the elevation in boiling point. So delta TB, the increase in boiling point, is equal to the difference of these two temperatures, that is T minus T0. Let's see, delta TB. This is very important, please. And this is the graphical representation of the elevation in boiling point. Delta TB is equal to T minus T0, and T is always more than T0. The boiling point of any solution is always more than the boiling point of pure solvent. And this increase in boiling point in case of water is always constant for a given amount of the solute. For a given amount of the solute. And practically it is found that the increase in boiling point is proportional to concentration of solution. Concentration of solution. Higher the concentration means higher the amount of solute, what is the concentration, and more is the increase in the boiling point of solution. This is very, very important. And here the concentration is taken in terms of molality. Molality. So molality means the number of mole of solute present in 1000 gram solvent. The number of mole of solute present in 1000 gram solvent is known as the molality of the given solution. And if we add the proportionality constant, that is Kb, is known as the molar elevation constant. That is delta Tb proportional to m. Delta Tb is equal to Kb into m, and Kb is known as the molar elevation constant or ebullioscopic constant. And this delta Tb is equal to Kb when m is 1. When m is 1. When m is 1. When the solution is 1 molar, and in case of water, the increase in boiling point is always 0.52. Maybe degree Celsius or K, because the difference is always same in Kelvin or in degree Celsius. 0.52. And this is the behavior of water. So this is the molar elevation constant of water, and it is always constant. It is always 0.52, and it is the property of water, not any compound. If we add 1 mole of any compound, maybe urea, maybe sucrose, maybe glucose in water, and solution is 1 molar, the increase in boiling point is always 0.52. That is why it is the behavior of water, pure water, not the solutes. Not the solutes. Now let's define molality and a numerical which we can solve by using this property, which is a very, very important numerical. It has use in chemistry. By using this behavior, we can determine practically the molecular mass of any unknown compound. Okay, molality. Suppose we have water and its weight is W1 gram, and to this we add some other compound whose molecular mass we have to determine. Its weight is W2 gram, whose molecular mass is M. Number of mole of the solute is equal to number of mole of solute is equal to weight in gram divided by molecular mass. So these are the number of mole of solute present in W1 gram of solvent. W2 over M, and the 1 gram of solvent contains divided by W1 and 1000 gram of solvent. 1000 gram of solvent means that water contain these number of mole of solute, and by definition it is the molality. So delta TB is the value of molality, small m. Delta TB is equal to Kb into W2 into 1000, or that is M into W1. So let's see, let the T be increase in boiling point of the solution. Kb known as the molar elevation constant, and it is constant for any given liquid. For example, for water it is 0.552, and for CCl4 its value is 5. Kb is 10 times in case of CCl4 as compared to water. This is very important please. So Kb is the behavior of a pure liquid. For water it is always 0.52, for CCl4 it is always 5, 10 times almost. It is the behavior or property of a pure liquid. Now we prepare a 5% solution of a non-compound, okay, a non-compound, and the elevation boiling point is 0.137 degrees Celsius. What is the molecular mass of the compound? Kb for water is equal to 0.52. So what is numerical? So we have a non-compound whose molecular mass is desired. We have to find out practically. That is the M, molecular mass. M is equal to, we have to determine Kb 0.52. 5% means 5 gram of compound. The weight of compound is 5 gram, and the increase in boiling point is 0.137 degrees C or Kelvin. Differential, it is difference, and W1 it is 95. Percentage means weight of solute present in 100 gram of given solution. So 5 plus 95 is equal to 100. That is your solute plus solvent, and the total weight is 100 gram. So by definition, 5% means weight of solute in gram present in 100 gram solution. 100 gram solution. So 0.5 is the molar elevation constant of water. What we are doing, we are adding 5 gram of a compound whose M is desired in 95 gram water, and we determine the boiling point of solution. Practically the increase in boiling point is found to be 0.137, and here the molecular mass comes out to be roughly 200 gram per mole, okay, or the molecular mass M is equal to 200 U or gram per mole. So in this way, elevation boiling point can be used for determining practically molecular mass of unknown compounds. Okay, please. Thanks. Namaskar.